Security misconfigurations are very common in a lot of different web applications, and they can happen whether you have an experienced team working on your application or a bunch of people who are sort of newer who are working on the application. It happens to everybody, and it becomes increasingly common as new technologies get released or new updates for the technology get released. So understanding where security misconfigurations can happen can help us locate those issues and be able to patch them when they happen or before they're discovered by anyone else. So one of the biggest things that typically happens is people will miss different types of security hardening. So things like this can be very simple. It can be things like compiling your application without protection such as stack protection. Stack protection can help prevent buffer overflows in applications. So when you turn off this flag, sometimes you get a more efficient program, but you'll also get something that's very more likely to be exploited with buffer overflows or those types of vulnerabilities. It can also happen with improperly configured cloud permissions. A lot of the time people will set up cloud environments, but they won't tweak the permissions and settings on them. From this, a lot of things can happen. I know recently there was a lot of talk about hard drive data being exposed from cloud instances, where you could literally just Google search for specific words and you can expose information from hard drives that shouldn't have been accessible from outside of the cloud environment. So these sorts of vulnerabilities come up fairly frequently in terms of missing those types of security hardenings. You have to have some awareness of what sort of security features you should be putting in place with, say, your cloud environments, so you can ensure that they're properly secured when people are attempting to access them. Sort of down the same sort of road as this is unnecessary features. This can include a lot of different aspects. Things like ports, accounts, and software are some of the most common. So to give you a few examples, if you have an application that ships on a server, for instance, that server could have software installed on it. And the software that's installed in it should only be the things that you're using. Same sort of idea as if you have a server running a web application, that server should only have applications installed on it that are actively being used. Otherwise, you can have old software that will be on older versions that will just expand the attack surface for someone attempting to attack your product. Enabling accounts that aren't used is a fairly straightforward idea. If you have accounts that are on the system, they should serve some sort of purpose, whether they're user accounts or administrative accounts or things for scheduling tasks. Setting up accounts that aren't actually used is a big problem because they could be potentially weak points where someone could attack and then do escalation of privilege to be able to compromise the account to get administrative access. The WASP piece here is enabling ports that don't need to be used, and a perfect example of this is the GhostCat vulnerability. With GhostCat, the AGP port was enabled, and it was allowing people to be able to get files that they shouldn't have been able to get or do remote code execution potentially. That AGP port was something that was very rarely used by anybody who was using Tomcat. For things like SAML, it was typically used, but there was a lot of instances where people had that AGP port enabled, but they weren't using it at all. So it just goes to show that when you default install an application, it's going to come with everything turned on essentially, and you need to be the one to turn off the things you aren't using, which means that you have to have a good understanding of what your application should actually be working with and what it should actually need in order for it to be running. So by understanding what your application needs and uses, you can lower the attack surface to the point where it's only things that are being used. That means you have to keep less stuff up to date and also less things for the attacker to be able to attack. Another place where we typically have security misconfigurations is in error handling. The most common is revealing stack traces to the user. If we run an exploit and we get an error, that error might expose information about what happened, and that exposure of information could tell us things about the actual system or service itself. It can tell us things about how the code is flowing through the application, where the error actually happened, what web pages are being accessed. It can give us a lot of information. So error handling is very important. Same sort of idea with creating error messages. If you make error messages that are too informative, you can expose too much information. The classic example is that username doesn't exist when someone tries to log in, tells them that they are trying to access a user that doesn't exist, which means that they could try a different user. So they gain information from the error message, which is something we don't really want to do. We want to balance error messages displaying useful information to the user, as well as error messages not exposing too much information to the user that they can learn something about the application's functionality, right? And then default configurations, which I sort of touched on with the idea of like the Tomcat AGP port. So when you install things, there'll be a default configuration. That default configuration is rarely, if ever, secure. You want to make sure that you are altering those default configurations to be as secure as possible. So changing default passwords, removing any default accounts, closing any ports that aren't using, stuff like that, right? So a lot of common attacks can leverage like default credentials, for instance, default configurations, just any sort of weakness that may exist on the system due to a default configuration can commonly be attacked. So in order to mitigate security misconfigurations, there's a few different things that we should keep in mind. The first is that we should create a repeatable process that we can do to complete our configuration on updates and upgrades. So for example, if we're going back to GhostCat, if I update Tomcat to the newest Apache Tomcat version, we also want to make sure that we apply all the same hardenings that we did to the previous version. So in order to do this, we should have some repeatable process that can sort of like automate that. So just like a quick script that we can run that runs through our configuration and sets it all up again when we have to update or upgrade components. Along with this, we should utilize a minimal platform with no unnecessary features. So if we're using like a Linux server, for instance, we should uninstall everything that we aren't using that isn't necessary. Anything that's default that comes with it that we don't need, we can just remove it. That way we can lower the attack surface and make things a little bit cleaner, right? In addition to this, if we're shipping the product to a client, we should advise the client on the proper security procedures and patches. If they need to apply anything after a patch is applied, or if they need to adjust anything on their system, they should know how those sort of things happen. And if we ever get any vulnerabilities reported to us, we should create test cases for them so we can ensure that regressions don't occur. So every single time we get in a vulnerability report, we create a test case, we patch it, we run our test case to make sure it doesn't work anymore. Every future version and every future patch, we run that vulnerability scan up against our system to make sure we didn't have any sort of regressions that are going to cause that vulnerability to come back. So these would be the sort of ways that you can mitigate security misconfigurations, and this will give you a general idea of how you can notice these misconfigurations to be able to detect and patch any sort of problems that come out of them.